Okay, everybody, welcome in. So, a couple things when we get started here. So, I am still ill. So, I'm chewing gum, which is kind of unprofessional, but it seems to help me from coughing as much during my conversation. So, I'm going to be chewing some gum. I will try to not smack it or make weird mouth noises, which I know um, are hard for people to listen to sometime, but otherwise, I'm just going to be coughing the whole time. And then I got my booster yesterday, and the first two shots I got, nothing. Didn't affect me at all. This booster is kind of messing me up. I feel like I'm getting over having the flu. So my brain's moving a little slow today, so just kind of just stick with me. If you have any questions, now's a great time to ask them. I will try to get your practice exam up later today. So I will get that posted today at some point. So those of you who want to plow into things, you can start looking at that today and start seeing what you can do with that. Wednesday's kind of your last time to meet with me and ask me questions. So, and we might try to meet up at a different time if you want to set up a Zoom meeting, but it's really hard once we enter finals week because I have to start moving forward on all sorts of stuff. So great idea would be to ask me questions Wednesday when we meet for the last time in this class. So your practice test will be up probably Wednesday. I will release either Wednesday or Thursday. I'll release the actual exam, which will be different, likely slightly shorter, slightly different problems on there. But I try to keep it pretty similar to the practice test, but I do reserve the right to change problems. The format will be slightly different than your exam 1 grade. Oh, now that I mentioned exam 1, I just remember there was an email that I didn't get back to. I'm a little confused if that's you who emailed me about your first exam and the retake. Just stick around after class and talk to me because I'm not quite sure what's going on. So talk to me, and then hopefully I can figure out what the situation is, and then fix it for you. Okay. Let's see. So I'll have the exam out probably Thursday. Just count on Thursday. It'll be available to you, and you have to have it taken by the time that the final exam closes. I can't accept anything after that. And then assuming I'm all feeling better again, I will try to plow through those grades and get everyone their grades submitted, and then the semester's over. Yay, you can go enjoy the holidays with whoever you enjoy the holidays with. So that's where we're going. We talked about inverses last time. I introduced logarithms last time. Oh, another question that came up, I had incorrectly labeled one of our class meetings. I guess that would be from last week. So basically, each time I bring up the streaming interface, it just takes whatever title you used last time and puts that up there. And I had forgotten to change that. So it looked like a stats class, but it was really an algebra class. So if I know I got an email from at least one student, in case there's anyone else who was trying to find that video, it should be easier to find now. Okay, so you can go back and check that out if you want to. If you're doing fine, then you don't have to worry about it and how that's going. Okay, so what does this mean when we talk about condensing logarithms and expanding logarithms? What is that? Well, the good news is it's excuse me. The good news is that they're basically the opposite operations. So you're using the same set of tools to condense logarithms as you are to expanding logarithms. So kind of once you start to get the hang of one, you kind of start to get the hang of the other. It's not really two separate topics. It's just, do you use the formula moving from left to right, or do you use the formula moving from right to left? One of them expands the logarithm, one of them condenses the logarithm. And essentially what we're trying to do here is simplify. We want to put things in a form where they are the most simplified. Now with logarithms, that can be a little bit sometimes of a, you could sometimes argue, well, I think this form is fully simplified. And someone could say, well, I think this other one is better simplified. So just pay attention to what they want you to put in the problems. But the key is recognizing these formulas, using them on a regular basis, getting practice with them. And then what will happen is you'll see that it's just a set of tools. It's basically your these logarithm rules, remember we talked last time and I kind of briefly said how it's not my favorite way of explaining it, but some people explain that logarithms are really exponents. So if you look at these logarithmic rules, you'll actually, you can kind of spot the exponents in there, right? Like when we're adding two things together, well, if logarithms are exponents and we add them together, well, remember we had an exponent rule where we added the exponents together. Sometimes we multiplied the exponents together. We're really just using those tools, but in a more complicated way to do things, okay? So the logarithm rules are, let's see, we don't have them listed here, do we? Let me see if I can find one. Oh, and I remember there was one question from last time that we ran out of time, but I wanted to address. So notice here in this logarithm, there's no base. There's no number down here that looks like a subscript. Remember, when there is no subscript written there for your log base, it means it's log base 10. We use a base 10 number system, so the assumption is oftentimes, probably the most used, is log 10. We have another log base that's a little more complicated, and that log base is E. So if you have a calculator or even a calculator on your computer, open it up, if you can find it. Open it up, and if you have it in scientific form, that's a long time for a calculator to open. Let's see. If you have it in scientific form, scientific notation for your, or scientific calculator, which you can just change if you're using Windows. You just go up here and change it. Standard, scientific, graphing, whatever. Oops. See how there's this button lowercase e right there? That lowercase e is a specific number. Just like pi right here is a specific number. Pi gets all sorts of, like, you know, people make parties for it and stuff. Pi is important, but I would argue that E has a bigger impact on your life than pi does. But we don't really teach the subtleties of that a lot of times. People don't appreciate it. So just recognize E is a specific base, but it's an irrational number. It's a decimal, really ugly decimal, infinite, non-repeating decimal expansion. That's why we don't want to write it out. You don't want to write E is 2.718, whatever. We just write E, the symbol E. So this is the second most commonly used base, is base E, and that we call the natural log. So when you see in these problems an ln, ln means natural log. You might go, wait, wouldn't ln be log natural? I think they took it from the from Latin, where it's a slightly different formulation. I mean, it's the same. It represents the same thing, but the words, the way you formulate the words, is a little bit differently. So ln, which we can even see right here, ln. So this log that has no base on it, that's a base 10 logarithm. This logarithm right here, that's the natural log. That's this base e. See that number e, 2.7182818284590 and on. It goes on forever like that without repeating the pattern. It's not, like some decimals go on forever, but it's like 5.454545454545 forever. In this case, there is no repeating pattern to this number, so we just represent it with an e. That's the natural log. So those are the two most used bases in logarithms, base 10 and base e. Base e gets used all over the place for calculating probabilities. It gets used for finance. It gets used for research, exponential growth, all sorts of stuff. It's highly useful, basically. Like I say, more useful than pi. Nothing against pi, but everyone gets kind of excited about pi. Doesn't help you nearly as much. But it's kind of difficult to deal with. Now, there are other logs. Depending on what you do in the future, you might end up using log base 4 or log base 5. I'd say the third most popular logarithm is log base 2, because when you're dealing with a computer, everything's binary. It's either ones or zeros. And so a lot of things are given in log base 2. Things like how much information can your computer process at a given time. These kinds of things you're basically counting ones and zeros and seeing where that goes. So log base 2 gets used for computers a lot. Log base 16 gets used for things once in a while. Like those of you who are artists, you've seen there's the, I forget what it's called, but sometimes numbers are represented in a base number system that is 16. So it goes up 0 to 10, and then it goes A, B, C, D, E, F for the other symbols that you need in order to compute that. So there are other logarithms that come up from time to time, but by and large, the two that you're going to use the most are base 10, which is this one that just says log, and the natural log, the one that says ln. Those are what you're going to use most of the time. Okay? So let's look at this log, condense the logarithm. In fact, let me pull something up first. You can just look this up, but I try to look stuff up off screen because you never know what weird thing's going to pop up when you're live and you think you've put in something innocent and then all of a sudden some weird things popping up. So logarithm rules and properties. So we have these different logarithm rules about how we simplify things. Now, for all of these rules, the bases have to match. We're not talking about a base 2 logarithm and combining it with a base 3 logarithm. Those cannot be combined in that way. Okay, so it's like the same with our exponent rules. They all had to have the same base. 2 to the 5 times 2 to the 7th is 2 to the 12th. We add those exponents together, but we can't do the same with 2 to the 5 times 3 to the 7th. We can't do the same thing there, right? So if you're confused, all you got to do is just literally just Google log rules or logarithm rules, log properties, logarithm properties, any of those is going to work perfectly fine, okay? So the first one, the logarithm product rule. Let's see if I can blow this up a little bit. Where are we? Oh, right. So let's say we have the log base b of x plus the log base b of y. So we're adding two logarithms together. This becomes the log base b of x times y. So you want to understand what this means, or you don't just try to memorize notation. I see students try to memorize notation and they don't actually understand anything that's going on. They're just trying to remember, oh, when I see this, I put it in the parentheses. That's a way to, it's not going to go well, right? It's not going to go well. So basically what this means is if we have the sum of two logs with the same base, we can combine them into the log base b of xy. Now this is basically just a, you can derive it right here by just going through and using your exponent rules to look at things. So what's an example here? Log base b 3 times 7 equals log base b 3 plus log base b 7. So see how we have these two logs with the same base being added together. That's the same as the log base b of 21. So we end up multiplying those together. And that might seem weird. Why am I adding on the right side of the equation, but I'm multiplying on the left side of the equation? Well, there's a couple things going on here. Remember, these logs can be considered exponents. So we're actually adding exponents together. But when we add exponents together, think of our rules of exponents. That really translates to a multiplication of the bases that we're trying to multiply together, right? So just be aware that you can combine these together in this way or separate them. So see how, say we have two logs on the right here, and if I start on the right and move to the left, that's where I'm condensing the log, right? So when they say condense the logarithm, what they want you to do is write the thing as a single logarithm, right? Get it all down to where it's just one single logarithm of what's probably a big mess, but they want you to compact that down into one logarithm. The other way is to expand it out into multiple logarithms. That's the expansion part. So remember here, if we go back, we've got our condensing logs and expanding logs. So the only thing here is that condensing means you're starting on the right side of these equations and moving to the left. That's condensing. Did I say that right? Condensing is starting on the right, moving to the left. Expanding is starting on the left and moving to the right. So you'll always know what it is they want you to do based on the directions that are being given. Either expand the thing or condense it down into a single logarithm, and you just have those rules to kind of figure out, right? So for instance, we could have, whoops, I didn't clean this part up yet. It's got stuff from my old class in here. Let me delete all that. So let's take, for example, the log of 1000x. There we go. And we're told to either simplify this or condense or expand, whatever it is we're asked to do. We want to move forward and do that thing. Well, I'm looking for my base here. Okay, that's a log problem, and I don't see any base, so that indicates to me that it's a log base 10. Anytime you have log base 10, it's not going to be written there, right? So you don't see the little 2 subscript underneath the G or whatever, because it's a 10, and when it's a 10, we don't write it. So using this rule, so we have 2 things that can multiply inside of this logarithm function, right? You want to understand the logarithm's a function. It's not the log times 1000x. The log is a function. You have to take the log of something. It would be like saying, like if we had a squared, we had some quantity being squared. The squaring is a function. It's not like a new object, a new number that we can multiply. So what we do is we have a log function. Its input is 1000x, and if we wanted to use, where is it? This rule right here, we could take the 2 products that are inside the parentheses and split them into 2 separate logs. So this would become this, right? So this is what we get if I use that logarithm to expand things. Okay, you might go, well, what was the point? Why did I do that? Well, this first part we can simplify, right? So we think about it. Let's see. Let's remember the parts of the logarithm, and this is why last time I said specifically, you need to be comfortable with that definition of the logarithm. If you are not, there's no hope in this chapter, right? So that should be, and it's actually not terribly complicated. So I'm not trying to tell you to give up on this chapter. I'm saying the first place to start is make sure you have that definition down, and you can go back and forth between the exponential version and the logarithm version that we were dealing with. So remember, this is log base 10, and this is our answer. So this is really saying, what power do I raise 10 to get 1,000? Okay, so 10 times, whoops, sorry about that. It looks like I had, my brain's not operating right. Looks like I had it on mute, so I forgot to unmute it. So thanks for pointing that out, Michael, that it's not working quite right. Sorry for any inconvenience that threw somebody, if that threw anybody off. So log of 1,000, you go, okay, what is the exponent that I raised 10 to get 1,000? So 10 times 10 is 100, times 10 is 1,000. So 10 cubed is 1,000, right? 10 cubed is 1,000. So that means this first logarithm part just simplifies to 3. So this just becomes 3 plus log x. Okay? Which is a little simpler than 1,000x. Log of 1,000x, 3 plus log x. Log x is a very basic function that you guys are and gals are going to get comfortable with in your college algebra, pre-calc, if you're slated for those classes. You'll get very comfortable with this. So it's actually much more convenient to have this in the form of 3 plus log x than it is of log of 1,000x. But really with logarithms, it just depends on what you're trying to do. It depends on what it is you're trying to do. You know, all this stuff. So just follow the directions, because you might go, well, wait, why am I expanding in this problem? Why am I condensing in this problem? It's just because they want you to know the basic rules for how to deal with logarithms. And then in your college algebra class, your pre-calculus class, then you're actually going to start diving into problems where you sort of have to really understand that logarithm and what it is. Okay. So let's do this one. Where were we? Condensing logarithms. Okay. 8 log A plus log D. So let's see. There's a few ways we could do it. There's another rule that we're now going to use. So it looks like we're going to use that addition one because we have the sum of 2 logs and they're both base 10. But what about this number in front? Well, we have a logarithm rule that says, where is it on here? They must have it. Where did it go? Here we go. The logarithm power rule. So notice if we have something in front of the log base b of x, it becomes the exponent on the input of the logarithm. So that means that we can really move this to be log a to the 8th, in which case this would become log a to the 8th times d. I think this should be what they want. Yeah. So you're just going to start using these the power property, the product property. You're just going to sort of have a toolbox of these different properties. And when you're doing one of these problems, you know, a lot of times students are like, well, how do I know which one to use? Just look at it, and if it looks like you can use that tool, then use it. Use it to your advantage, right? Go, oh, okay, I think I can make this work. So it's telling you you've got the power property, you've got the product property. You can Google all of these. You might go, well, I don't have a specific book that has these listed. They're literally everywhere. So just Google log rules, logarithm rules, log properties, logarithm properties. There are tons of sites like this that just have them listed for you, so you can go through and do them. Derivative and integral, those are calculus concepts, so you don't have to worry about these ones right here. The derivative and logarithm, just ignore those. The logarithm of 0. What is the logarithm of 0? The logarithm of 0 would be 1. All right, if you think about it in terms of, let's look at it because it confuses some people. If we look at it in terms of, so let's say we have, sorry, let me double check. How do I want to? Oh, that's not the one I want to talk about. I want to talk about this one, the logarithm of 1. So if we have something equaling 1, so let's say we have the log base 2 of 1. Okay, so log base 2 of 1. How would you simplify this? Well, remember, the subscript is your base, and the thing up here is your answer. So we're asking, like if we wrote it this way, y equals log base 2 of 1, then you're really asking, what is the exponent that I would raise 2 to get the answer of 1? Well, remember, one of our exponent rules is that anything raised to the 0 exponent is 1. So in this case, the answer is 1. Sorry, 0. The answer is 0. Anything raised to the 0 exponent is 1. So 2 to the 0 equals 1. That's that translation. Remember we talked about translating using the definition? This means that 2 to the y equals 1. Well, there's only one exponent you can raise 2 to get an answer of 1, and that answer is 0. So that's where this rule comes from. The log base anything of 1 equals 0. Okay. This one makes sense too. The log base b of b equals 1. So let's kind of translate that, because what I want to show you is how to break these down, because otherwise if you just look at them and you're like, it's all about memorization. It's all about memorization. Trust me, I watch people try to memorize this stuff all the time. It's not going to turn out well. But if you understand what that logarithm means, it's going to, if you understand what that thing means, then you can think your way through it, right? I don't remember exactly, there's a question about the homeworks. I don't remember exactly what homework like where stuff comes up where, but there's definitely stuff I have to show you in this class so that you'll be prepared for whatever your next class is. You'll be ready for the for those problems, even if you didn't specifically have some homework on it yet. But that's a good point to make. Okay, so let's think about this one. So let's say we have y equals the log base 2 of 2. So this can be confusing. You're like, log base 2 of 2, what is that supposed to mean? Well, let's convert it to its exponential form. That means that we have 2 raised to a power equals 2. Well, 2 raised to what power is 2? 1. The answer is 1, right? So y must be 1 in this case. So that gives us this logarithm simplification rule right here. So you just kind of learn these rules. Again, don't learn the calculus ones. You'll learn those in Calc 1. Maybe Calc 2, I forget where they are now. But either in Calc 1 or Calc 2, you'll learn these if you're someone who has to take Calc 1 or Calc 2. But we don't need them for now because we're not learning calculus in here. Let's see. Right, so notice if you have the division of two things inside of your parentheses for your log function, you end up subtracting the logs. So it's a lot like the product rule, except it's the quotient rule because your division implies subtraction over here. So what is this about? That seems kind of weird. Remember when we were canceling things using exponents, things like b to the 4th over b squared equals. Remember stuff like this from the exponent part? Well, we have a quotient, right? We have one thing in the numerator, one thing in the denominator. They're being divided. What did we end up doing in that rule? We ended up subtracting the exponents. Well, we can kind of see that. We have a quotient going on here that are exponents, so we end up subtracting the logs. So it takes a little bit of work, but you can literally prove these rules just by manipulating the exponent rules. Like take this logarithm, convert it into exponent form, do the exponent work that you learned a couple chapters ago, and then turn it back into a logarithm, and you'll have the right side. So you can literally sit down and like prove these things. Okay. So that's that log property right there. So we've looked at the first three, and those are kind of the big ones. Hold on, I need to get some water. Sorry about that. I'm losing my ability to speak here. Yeah, the dog's good. He recovered faster than... He sort of recovered like immediately, which is good. I didn't recover immediately, so I'll have to look at that. Okay, so thanks for asking. So let's see, where are we? Where was I? We're looking at the log rules. Those are, we don't need, okay. So let's look at a couple more problems here. Okay, so write the expression below as a single logarithm in its simplest form. So we have log base b. So what does that mean when we have log base b? It means it can basically stand for any legitimate b value. So oftentimes these are integers, but they don't have to be. They're positive integers, but you can also have base 2.7, right? Like e, like we talked about earlier. So b is just kind of a stand-in for whatever base you need. So let's take a look. We want to write the expression below as a single logarithm in simplest form. Okay, let's take a look. Log base b10. So we have log base b of 10 plus 2 log base b of 3. Okay. Plus 2 log base b of 3. Is that right? Okay, log base b of 10 plus 2 log base 3. Okay, so we want to condense this down as much as we can. I don't need both of these open. What is this? Okay, so we want to combine these together. So I see a few things going on that kind of clue me into rules I might be using. I see I have this one rule about when we have a coefficient out in front of the log, which is basically this rule right here, this thing. So I'm probably going to end up using the power rule at some point. And then also we have the sum of two logs. So that would indicate to me probably going to use this top one as well. So I'm looking for an opportunity to use this first log rule right here and the third log rule. Probably going to have to use those in order to get through everything. Okay, so sometimes you have some choice about what order you want to use these log rules. Sometimes it doesn't matter, sometimes it does. So unfortunately, there's not like a golden rule I can give you that says, in this circumstance, always use this rule, this log rule, always do this. It's really just a matter of experience. You do enough of these problems and you play with it and you start to get a sense of how that works. Okay, so we want to simplify. So let's see. Before I can do that, I really need to take care of this exponent piece. So in this case, it does matter what order we do this in, because if you think about it, when we combine them together, one of the logs would have a 2 in front and one of them wouldn't, but now there's only one log. So would the 2 go there or not? And the answer is we can't do that rule first. So what I would do then is I would use this third rule, the logarithm power rule, that says if I have a number out front of my log, it becomes the exponent on my base. So that would look like, I keep pressing the wrong button here. That's going to look like log base b of 10 plus log base b of 3 squared. Now I'm only writing 3 squared so you can see what mathematical operation we did. Okay, but it's basically this rule where it says the number out front becomes the exponent on this inner part. Now we know what 3 squared is, so you should not be doing problems where you keep writing 3 squared. I'm writing 3 squared so that you can see how did he get 9? I'm just showing you the 2 moved from here front up to the exponent. It's now 3 squared. So this really just becomes where am I? This just becomes a 9, right? Oops. So you can see the 3 squared just became a 9. Nothing fancy, nothing new, nothing weird about that. 3 squared is equal to 9. You've known that for a long time. Okay. Notice how we took care of that one log rule. Now the only thing left I see to do is use this first rule, the logarithm product rule. So now I'm going to do that. So that means that they're going to be what? Multiplied inside, right? We take the two things that are over here in our logarithms and we multiply them inside here. So I'm going to write it out just so you can see where it comes from. Most of you, when you do this problem, would not take as many steps as I am. But I'm writing lots of steps so I don't lose anybody. And if you want to write lots of steps, it's always a great idea. Okay. So this would become, can't seem to not press that wrong button there. This would become the log base b of 10 times 9. Yeah, there we go, 10 times 9. So see how I'm just multiplying the parts from up here? And of course, we don't leave things as 10 times 9. That's not fully simplified. We would leave that as 90. So we've got the log base b of 90. Should be our final answer. So let's see if I'm right here. Log base b of 90. Oops, you can't see the... So I'm just putting 90 in there because they already have the log base b on here. And there you go, we got it right. Okay, so you can see they did the same thing we did. Take care of this, make it 3 squared, which becomes a 9. 10 times 9 is 90. Boom, we're done. So it's just a matter of understanding those rules and then working your way through them, okay? Let's see about the other direction. Oops. Okay, so when they say expand, they generally just mean do the opposite of condense. So what would you do here? You would bring the 3 down in front, and then you would separate this. So log 8x cubed. Let's take a look. Log. And it was just base 10. Okay, log of 8x cubed. Now, what exactly are the directions? Because there's a few things you could do here. Expand the logarithm fully using the properties of logs to express the final answer in terms of log x. Okay. Let's see what we're going to do there. We want to expand the thing out. Okay. So I do see a product in here. I see an 8 times an x cubed. So what I can do is I can expand that out to be log 8 plus log. And remember, log is just short for logarithm. It's a long word. Log x cubed. What is happening here? Why is it not? Oh, I didn't leave a space there, so it thought the x was part of the log. Here we go. Okay, so I just used this first rule, but I used it in the opposite direction that we were previously. Before we were taking logarithms and combining them into a single one. Now I'm starting on the left and moving to the right where I use this rule to separate them. So a lot of times formulas in mathematics, you just use one direction, right? But this is one where you're going to use both directions depending on whether it says expand or condense. You're going to go through and do that. Okay. But we're not done because it wants it in terms of log x. We don't have it in terms of log x. We have it in terms of log x cubed. Okay. So this would be log 8 plus Okay, so in fact, in this case, remember, we can use, where did it go? This rule that says if I have an exponent on my input into my log, I can bring that down in front of the logarithm. So we can actually make this be 3 times log x. And this is what that should look like. So let's see, log 8 plus 3 log x. So log 8 plus 3 log x. Should look like that. Let's see. Yep, there we go. So same steps I did, right? And it looks easy when they're putting it here. I know it's super confusing when you're first learning logarithms, but just break it down into these individual rules that we're using over here. Log AB equals log A plus log B. So we just expanded it. And then down here, we brought the exponent down in front. And that gives us our answer there. Okay. They do get slightly more complicated. So this is what? You're going to expand this into 2 separate logs, but it's going to be with a subtraction. Since here we have a quotient of the inputs, that means you're looking at this second rule, right? Here's the quotient of the inputs, and you're subtracting the logarithms that you expand this out into. So we'll end up with a subtraction, as well as one of them's going to, this exponent on one of them is going to become a coefficient on the logarithm, right? So let's see, this would become what? Log x minus 3 log y minus log z. So we end up subtracting the stuff that's in the denominator because that's the part that's being divided. And then notice that I brought this 3 out in front because that's this rule right here, the power rule. These first 3 rules are the ones you're going to use the most, especially since this is an introductory chapter. You're going to use those a bunch. So let's see if I did it right. There we go. So now you can see getting a little longer. Some of these, we were kind of doing problems where you had to use 2 log rules. Now here it looks like we used 3 log rules plus a distributed property. Okay. So they can get more complex. You can get, you will like run across problems like in pre-calc, the hard ones, you might use 8 or 9 log rules before you can finish the thing. Yeah. So that's kind of where we're at with that. Let me just double check what the last one looks like. Oh yeah, here they're just having you plug stuff in. So that shouldn't be too difficult. That's just simplifying some logs. So that should be fine. So there's a good question here. Wednesday is the last class meeting, correct? You will open up the practice exam when? My goal when we finish this class in a couple minutes is to write that practice exam and put it up and then go collapse and have, Netflix or HBO or whatever on and just sort of try to get through the day here. So that's my goal is I'm going to sit down and write that thing right now, try to get it out to you, and then I'll hopefully be feeling quite a bit better in a couple days from now. What I will say is because of when we took the first exam in this class, my account had been messed up because my subscription had ended a couple days before, which means it didn't actually allow me to use the testing type environment. So I had to use a different assignment in order to go through and do that. And I hadn't figured out yet because that's kind of weird that they don't normally places notify you, hey, your subscription ended. That's why that's why some of your features are not working right. It just happened to happen right when I released that Math 3 test, and I thought they had just changed the way they were doing stuff. So just so you know, when you take that final exam coming up, the setup will be slightly different, not in any kind of scary way, but it will be set up a little bit different than that test. It'll be more like a test-like environment. So just kind of treat it like you get one shot at each problem. You got to go through it and make that work. Okay? So I'll get that practice test up for you. The practice test will resemble more like a homework because I don't want it to put it into the test grade portion. So it'll still be classified as a homework problem, but the test that you get in a few days will be under a different set of rules. Basically, once you start the test, you're only going to have a few hours to finish it. And I don't know, sometimes I put 8 hours on there, sometimes 5. So there's no rush to finish it, but you can't like start it on Wednesday and then finish it on Friday. It's kind of like when you rent a movie from Amazon sometimes and they're like, oh, this rental is available for 30 days, but once you start watching it, you have 48 hours to finish it. It's kind of the same here where you pick your window, but once you start it, you get just a few sorry, you get just a few hours in order to finish it. How many questions are on the final? I don't know. I honestly don't know. I'm not known for putting excessive problems on exams. I've never really much seen the point of having someone do like 30 factoring problems. So it'll just be sort of go back. I look at the chapters and I ask you stuff that you're going to have to do. Now, most of the material will cover what we've done in the second half of the course since the last exam. But I do reserve the right to put a couple problems on there from the first half of the course. So you can probably count on having to find the equation of a line given 2 points. I pretty much always put that one on the final. So remember the problems you did where it's like, here's 2 points, find the line that goes through it. You're probably going to have to do that. Solving a system of equations, you're going to have to do one of those. So most problems will be from the second half, but I do go back and just go, I should pick at least one problem. I reserve the right to pick at least one problem from the earlier chapters and put them on that test. So don't just focus on the second half work. Make sure you remember how to solve a system of equation and stuff like that. And the good news is most of you have already learned it. So going back and reviewing that material won't take too much time, right? The hard thing's going to be kind of wrapping your brain around logarithms and the quadratic formula and stuff like that. That's kind of newer, right? More complicated and newer. Will you be putting word problems from the first section in the final? Depends what you mean from the first section. I do reserve the right to put word problems on the final. So there could be word problems from any chapter on the final exam. That is definitely a possibility, and very likely that you would have at least one word problem to work through. Potentially many. I don't like the beginning of class. It depends what you mean. I don't really remember when we were doing that, but the answer is yes. You could have word problems from any chapter in the book. Those could potentially pop up. And again, that's one of the reasons that you don't want to focus on memorizing like how to do a specific type of problem. You want to learn how this stuff works, because then it's not really any different doing a word problem versus a non-word problem, because it's really a matter of understanding the mathematics. Okay. So anyone is welcome to stick around in Zoom. Ask me whatever you want regarding the class so that I can give you the information that you need in order to finish successfully. So feel free to hop into Zoom, ask me questions. Otherwise, once everyone's done in Zoom asking me questions, I will get the practice test posted, and then I'm going to go lie down. Okay? Thanks, everybody, and I will see you in a couple days.